Okay, so the last, it's not necessarily the last new thing, but we are going to talk about word problems, but this is going to be the last possibility of solving a system, and we're going to be solving a system of linear inequalities. Okay, so what is a system of linear inequalities? Oh, help. Would help if I would spell correctly. There we go. So it is two or more linear inequalities with the same two variables. Same sort of idea as a system of equations. Okay. So a solution, this is an interesting one. Solution to a system of linear inequalities is going to be the set of ordered pairs that satisfy or makes true all of the inequalities in that system. Okay, so if you think about it, when we did linear inequalities, we would graph a boundary line and then we would shade in half a plane. Well, now we're going to put two linear inequalities on the same set of axes. So there's going to be two lines, dashed or solid, dash, dash, solid, solid, it just depends, and then two sets of shading. Okay, so, that's going to be interesting. So the solution set, still looks funny, is going to represent, it's going to represented by the overlap or intersection of the graphs of the inequalities. Okay, that looks terrible, sorry. Let me write that a little nicer. Okay. So, what is it actually going to be? It's going to be a wedge, okay? That's really what it's going to be. So, you're going to have a portion of each boundary line. So, you're going to have each inequality's boundary line, one portion of it is going to be on either side of this set of solutions. And then there's going to be a doubly or mutually shaded region. So I'm just going to tell you right now, super duper important that you check before you shade. Now, I'm going to go to the next screen just so I have plenty of room. And I am going to pop up, if I can remember how to do it, some graph paper. Too small. Better. That's kind of big. Maybe I should go with small. I'll go with a small. Okay. I love how I talk to myself. So our first problem, the directions are going to say, solve the system of linear inequalities. Solve the system of linear inequalities by graphing. And this is the only way you can solve them. It's not by guessing what the answer is, because there's an infinite amount of them. Okay? So you're going to be given two inequalities. Sometimes they'll be written in slope-intercept form. Sometimes they'll not be, and you'll have to get them into slope-intercept form before you can try to do anything. So I'm going to add that as a note over here. Must be in slope-intercept form. Oops, sorry. I didn't want that. I wanted a star. Okay, so if it's not that, then you won't be able to graph it. So make sure you get it turned that way. So this one's pretty cool. I've got all the data that I need. Slope is going to be -2. I wrote 2. -2 over 1. And the y-intercept is 1. I'm looking at my inequality. Because it's solved for y, now I can identify whether I'm going to be graphing right or left. But it's going to be a dashed line, and it's going to be shading above. So I'm going to go ahead and test 0, 0. Zero is greater than 1. That's false, so what it says is this line will not be shaded over 0, 0. All right, let's try the next guy. I'm going to do different colors with him, and I'll color in different colors. So let's see, we've got, let's see, slope is going to be 1 over 1. That's how I'm going to move from one point to the next, and the y-intercept is 3. We have a less than or equal to sign, so it's going to be a solid line, and I'm going to shade below. All right, so I am going to test 0, 0. So is 0 less than or equal to 0 plus 3? Is 0 less than or equal to 3? And that's true. Well, let me write T for true. So that means this line will get shaded over 0, 0. All right, so let's go ahead and see what my graph needs to look like. I think I'll put them over here. Well, it doesn't matter really. So I'm going down, I'm going up. I'm going to make my line kind of look like this, because I have mainly positives. So I have X and I have Y. I think I'm going to count 2 boxes for 1. So 2, 4. 2, 4. -2, and that should be good. So I'm going to go ahead and find where B equals 1. I'm going to rise down 2 and to the right 1. So that's going to be dashed. So notice I make that boundary line go about all the way across the graph. And then we shade it above, which should not cross 0, 0, and that's the case. I could highlight. So having two different colors is really helpful on this one. And then we're going to go to where b equals 3. We're going to rise up 1 and to the right 1. So this is going to be a solid line. And we're going to shade below, which will cover 0, 0. And then what we're going to do is highlight the solution. So it's going to involve both boundary lines. Okay, and then everything in between. So everything there would be a solution. So it includes the boundary lines. It includes the mutually or doubly shaded region. Okay? All right, let's try another one. Keep my graph paper. So this one, oh, not so nice. Same directions. We have 3x minus y is greater than or equal to 2. 3x minus y is less than negative 5. So we're going to go ahead and subtract 3x from both sides. That's going to give me negative y is greater than or equal to negative 3x plus 2. Divide by negative 1. And then we get y, oops, going to flip my inequality around, 3x plus 2. So we get a slope of 3 over 1 and a y-intercept of 2. The less than or equal to is going to give me solid and below. I'm going to test 0, 0. So 3 times 0 minus 0, is that greater than or equal to 2? Is 0 less than or greater than or equal to 2? So notice that I went back to the original problem, and that is false. So what that says, I wouldn't be shading over 0, 0. Okay, next guy. Again, we have to solve. So we start by subtracting 3x from both sides. We get negative y is less than negative 3x minus 5. Divide everything by negative 1, flipping the inequality again to greater than, and we get 3x plus 5. So the slope is 3 over 1, and the y-intercept is 5. Now we have greater than, which is going to be dashed, and shading above. And then we're going to test 0, 0. Back to the original. 3 times 0 minus 0. Is that less than negative 5? Is 0 less than negative 5? No, that's false as well. 0 is greater than that. So, again, it's not going to shade over that. So I'm going to go ahead and graph. I'm going to do it over to the side. So let's see. I need to go all the way to 5 and 2 and rise up. Okay, so it's pretty tall. So I'm not going to be rising down at all. So here's my x, here's my y. Keep those intervals the same distance. Okay. So the first guy, we go to where the y-intercept is 2. we're going to rise up 3 and to the right 1. So that takes me to 1, 5. That is a solid line. And we are shading below. Oh, and that should cover 0, 0. That's interesting. Let's see. Oh, I know what I did. I blew it. I blew it. I blew it. That's a negative. Oh my gosh, I'm so glad I caught that. Well, eventually, right? So my y-intercept is negative 2. Go back over here. That's a negative 2. And then is 0 greater than negative 2? And yes, it is. So, oh, all this erasing. Let's try this again. So that is true. So then 0, 0, I'm going to shade over. Okay, now that's making more sense. So I'm going to shade below. It is going to cover 0, 0. All right, the next guy, let's see, I'm going to go where B is 5. Let me double check I didn't do anything bad there. Nope, 2 negatives make a positive. Okay, I'm going to rise up 1, 2, 3, and to the right 1. This one is going to be dashed. Oh, that's interesting. And I'm going to shade above. Definitely doesn't intersect with 0. Now, you might have already noticed that the slopes were the same, and that should be an indication that we were going to have parallel lines. But not all parallel lines have this problem. Sometimes the parallel lines do overlap their shading. But in this particular case, the answer here would be no solution. And the reason is there's no overlap. So there's nothing the two have in common. So there you go. All right, I don't think I have another one. Let me double check. Nope, that's it. Good luck, guys. Bye now.